Welcome to this explainer. Today, we're going to demystify your home's consumer unit and reveal the technological guardians that are literally keeping you safe from electrical hazards every single day. You know, electricity is this invisible, incredibly powerful force that we just casually invite into our homes. We flip a switch, lights come on. Plug in a kettle, water boils. It's magic, right? Well, behind that unassuming little plastic door in your hallway or garage lies a super complex, highly engineered system that has one primary goal: to keep you alive. And today, we're going to break down exactly how the whole shebang works.
All right, let's take a super quick look at our agenda. We're mapping out our electrical road trip today, starting from the street, exploring the 3 vital wires, meeting the RCD and MCB guardians, tracing the safe return path, and then finishing up with a really practical reset checklist for those moments when you're suddenly left in the dark.
Okay, so Section 1, the journey to the home, or what I like to call the outer walls of the electrical fortress.
To really understand how your home is protected, we first have to trace the journey of electricity as it actually arrives from your local substation. Because power doesn't just magically appear in your outlets, right? It takes a very specific path. So a service cable, either running overhead or buried underground, taps into the local distribution grid and comes straight to your property. First stop? It passes through the service head, which holds your main fuse. This fuse usually handles between 60 and 100 amps, and it basically acts as the outermost wall of your electrical fortress, making absolutely sure a massive surge doesn't just overwhelm your house. After that, it flows into the electricity meter, which just tallies up your energy consumption. And finally, the power arrives at the consumer unit itself. Specifically, it hits the main double-pole isolation switch. This is that big manual switch you can use to just cut power to the entire board all at once.
Moving right along to Section 2, the 3 vital wires: phase, neutral, and earth.
Let's look at the 3 primary actors making this electrical journey possible inside those cables. The basic mechanics here are actually pretty cool. First, you've got the phase wire. Sometimes people call it the live wire. This is the one that brings the active, dangerous energy right into your property. Then there's the neutral wire, which simply carries that energy back to the source once it's done its job. And finally, we have the earth wire, easily spotted by its green and yellow stripes. Now, this one normally carries no current at all. It just sits there, completely waiting on standby, acting entirely as an emergency escape route for rogue electricity.
Which brings us to Section 3, the RCD Guardian. This is your ultimate anti-shock protection. So, moving past that main manual switch we talked about, we hit our first real inner defense inside the consumer unit: the residual current device, or RCD for short. I want you to think of the RCD as a highly strict accountant who is just constantly balancing a ledger. The electricity flowing into your house on the phase wire absolutely must equal the electricity flowing back out on the neutral wire. If this accountant sees that the current going in doesn't perfectly match what's coming back out, it knows there's a residual current, basically a leak somewhere. And a leak usually means the current is finding some different path to the ground, which is a massive, massive hazard.
Now, to put that into perspective, I want to talk about an incredibly small number: 30 milliamps. If our strict RCD accountant notices a difference of just 30 milliamps, it instantly cuts the power in a fraction of a second. But why 30 milliamps? Well, because that is the tiny, fatal amount of electricity that can actually cause cardiac arrest if it passes through a human body to the ground. If you were to accidentally touch a live wire, the electricity would bypass the neutral return and travel right through you. The RCD instantly detects that missing 30 milliamps and trips, quite literally saving your life on the spot.
Let's jump to Section 4, the MCB Guardian, which is all about stopping overloads.
Connected directly after the RCD via metal conductive busbar, we find our very next line of defense: the miniature circuit breaker. If the RCD is an accountant, you can think of the MCB as a traffic cop. While the RCD looks at the whole section to prevent life-threatening shocks, the MCB watches individual smaller circuits, like say just your downstairs lights or just your kitchen sockets. And it's keeping an eye out for 2 main things: congestion and pileups. Congestion is basically an overload. That happens when you gradually plug in way too many heavy appliances on one single circuit. A pileup is a short circuit, like when a phase wire directly touches a neutral wire. That creates an instantaneous, massive spike in current that generates a magnetic field inside the MCB, forcing it to trip immediately to protect the whole system.
So, the absolutely crucial takeaway here is understanding the difference between these 2 components. There really are a tag team of safety, but they do completely different jobs. The RCD protects you, the human, from deadly electric shocks by looking out for those tiny imbalances.
The MZB, on the other hand, protects your home's wiring from melting or starting a fire by monitoring the total current volume. So for example, it'll trip if a 32 amp limit on your plug sockets gets exceeded.
All right, Section 5, returning safely and the path back to the source.
Now that the power has done its job, lighting up your living room, boiling your kettle, let's look at how it safely exits to build a complete continuous loop. Electricity flows right out of the appliance, travels along the individual neutral wires, and gathers all together at the neutral block inside the consumer unit. From there, it has to pass back through the RCD. Remember our accountant? Well, this is where the RCD does that final super important balance check against the incoming phase current. Once it's cleared, the power flows through the main switch, back out through the meter, past the service head, and straight out to the street's main distribution cables.
But hey, what if things actually do go wrong? Let's say a live phase wire inside your washing machine somehow comes loose and touches the metal casing. If you were to touch that machine, you'd get a horrible shock. And this is exactly where the green and yellow earth wire steps in. It connects that metal casing directly back to the consumer unit's earthing block. The rogue electricity basically flows down the earth wire, creating an imbalance that the RCD detects, which then trips the power instantly. And depending on how your specific home is set up, that earth path is carried safely away to the ground via a connection to the service neutral, the metal sheath of the underground cable, or maybe even a direct copper electrode rod that's literally driven into the earth right outside your house.
Finally, Section 6, the breaker reset checklist, or what to do when you're suddenly standing in the dark.
We've all been there, right? Standing in the hallway, holding your phone flashlight, wondering what on earth to do next. When the lights go out, open up that plastic door and look closely. You need to ask yourself, did an MCB trip or did the main RCD trip? If it's an RCD, you've got a current leak. Unplug all your recently used appliances. Seriously, it is so often just a faulty kettle or toaster where the power is leaking over to the earth wire. Now, if it's an MCB, you likely overloaded a specific circuit. Maybe you had a space heater, a hairdryer, and a microwave all running at the exact same time on the same line. These switches do need to be manually flipped back up to restore your power, but please remember this. Just forcing the switch back up does not magically fix the root problem. If you flip it and it immediately trips again, the Guardian is doing its job. You have to locate and remove that hazard.
And that pretty much wraps up our explainer on your home's incredible electrical defenses. Hopefully this gives you a real sense of peace of mind, knowing exactly what is going on behind that little plastic door. But I'll leave you with this thought. The next time you're left in the dark with a sudden loud clack coming from the hallway, will you know exactly which invisible guardian just stepped in to save your life?